How's it going, everyone? Eudero Gonzalez here. Today, we're going to explore now what the RxGX is this thing is all about. And why we need to look at RxGS, these specific libraries, and how do we get here? Because once we understand that, you will embrace complexity. So, this is a very interesting story that it all started with the rise of computing, something that Grady Butch mentioned, that the history of computing was woven on the loom of sorrow. And at least from the 20th centuries, where after the Second World War, now the United States, followed by some of the generals, they get it together to actually found some of these corporations that allow them to have is funds and control of how we're going to now process stuff, or how now can we reuse some of these technologies that was developed during wartime right now. And uh, to make the story short, the TLDR is that because in the 50 and the 60, now a lot of our applications, they need to be or they were now conceived as this algorithmic way. So the way of how do we decompose systems was through algorithm. And that's why we have, for example, language like Fortran and COBOL, and even in its name, it tells you what it is, a Fortran. So with which is formula transcription. So, and because of that, those programs and the way how programmers actually now orchestrate and define all of this set of algorithms that initially was made by uh, computers way before the rise of these mini computers, or at least these supercomputers like ENIAC. They have something to their the main components to actually calculate that. The main physical component was relays, and how relays were so big and expensive to actually just to run some sort of computations. And how now that we move on to from relay, which is a very interesting thing of how the relay works. So when you pass an electric charge to a circuit with a relay, now on that particular relay, it enables an electromagnetic field that whatever metal piece are on top of that is going to not be attract for that. And this is something that how you can now essentially is have a switch, pretty much like the switches you have in your bedroom, kitchen, or your house. So with this switch, they're now much more better an alternative, and some of the brilliant minds, followed by von Neumann and among others, that I need to dive into those areas a little bit more to understand again how do we get here. They quickly realize that, or not that quickly, is hey, we need to find a way is to better is to make better use of our computers by using something different. Instead of relay, let's going to now try this stuff called light bulbs or vacuum bulbs. So these vacuum bulbs that after all they are, as the name suggests, light bulb, but a little bit more larger. Now this is how back in the old days we actually instruct these machines to do stuff. In other words, it's another kind of switch or representations. So again, because those uh, vacuum bulbs were so massive as well, but it now represents a little bit more. They're uh, in, um, in contrast with relays, they were more easy to set up, and of course there is some trade-off because now this incandescent bulb actually attracts some of this bugs, and that's why we have now the term bugs here on the language. And then how with the research of how can we now make this computation or these systems, these computation systems much more scalable, now is when it was developed this little piece of technology like is transistors. So again, this is just to describe a little bit of history to now when we're writing our JavaScript application, which is now how this uh, line of codes are being translated by the machines into zeros and ones, and to switch all of these zeros and ones is so fast that we can actually have this kind of real-time videos. uh, we are not only care about how we write our applications in this monolithic sense or in this isolated sense, but also how can we now distribute that computing. So this is not a problem exclusively for the computers, or at least for JavaScript particularly, uh, because this is something that a lot of those complex problems and architectures, most of them was designed on the defense sectors, not on the consumer sectors. So now we reach to a point where we inherit all of these particularly techniques and technologies based on the hard works of a lot of people. So we are now stand on the shoulders of giants. So because they pass the torch to us, and now we are going to write these JavaScript applications in the commercial sectors. It also can be in the defense sector, but in the commercial sector, where we say, hey, you know what? We want you to actually give us a certainty that when you're writing your code actually works as expected. And if we need to communicate with external systems, let's going to do that in a way that is sustainable and economically interesting. So we not only be able, responsible to the JavaScript developers to write this kind of applications to provide now interactivity on the web, but also is to communicate to other services, to other computers. And there are several techniques that allow us to do that. And because the nature of JavaScript, that it say, hey, I was designed in 7 days to now evaluate statement one at a time in an interpreted way, unlike compile, which is, hey, give me everything first and then let me analyze that, and if everything is right, all right, now I'm going to execute this. Where now an interpreter, it says pretty much like an interpreter for a high profile individuals or politicians and all that kind of stuff, is, hey, we have now this machines that we're going to indicate all of this set of instructions one after the another, all right? And we have to be careful about how do we tell this kind of instructions. So that's one for building this user interface, and building this now interactivity, this web application, that one component is, hey, how do we design and maintain applications, which is that there is a different course there that actually now Steve Keeney actually described that, and also we can dive into that, but not in today's video, which is a good thing. And the other is what is relevant for us is how do we handle the concurrency in our applications. So because this concurrency is something that we need to deal, and this is all of these tasks that overlaps at a time. So if you see that timeline, if you see time as a vector that you move down or that you walk through, and then suddenly all of these different things happens and needs to be handled at some point. So for example, when you are now at the bathroom and suddenly someone actually called you and it's your mom and you need to attend, you say, hey, no, I don't want to hang I don't want to hang this man. Let me actually do my business first, and then I can handle that. And it can also during that moment, perhaps the toilet doesn't flush, and then you have now another problem here is that all of these different things that can happen at a time. So there are several techniques now in JavaScript, particularly from the web platforms. They are not natively in JavaScript that we need to actually take a look. And I'm going to explain that briefly in what are the challenges that we need to deal with. So first is callbacks. So now callbacks with timers is now providing a way to make the computations to be run at some point in the future. I don't know when, but do that at some point. And there generate some trust issues, right? So hey, I don't want you to run too many times, too few times, too early, too late, don't swallow up errors, preserve the data context. And even though callbacks, specifically the timers, which is something that is provided by the platform, is not natively to JavaScript, allow us to do this. There are also another challenge when writing these concurrency applications, like, hey, they are not reasonable. They are not reason about. They're not easy to reason. They're not reasonable. So, and also is the time, because now we have to coordinate is when this response came. So we need to coordinate is when this response comes in and respond them accordingly, so we can show them in the proper order that they were called. Thongs say, I'm going to help you here, which is a technique that way predate JavaScript. Is say, hey, this is now a technique that people before you now have the same problem, and they say, hey, this is the technique that we come up for that. Thongs, which is give a function everything that it needs, and then let's going to wrap that, so every time we call that, we get the same value out of this. So this will act like a token from the synchronous perspective, and from the asynchronous perspective is say, hey, this async function, or this function that needs to be run at some point in the future, give it everything that it needs, all right? And let's going to wrap that into a function that is going to accept a callback to get the value out of that once that is done. So this is huge and important, because now we eliminate time as a concerning factor in our code. And this is a tool that you can get into your toolbed. So, because even though we don't solve the problem of the inversion control or this trust issue generated by callbacks, now we have this called thing promise. So promise, which comes from another language called E, that was created by Mark Miller, among other TC39 members, TC39 commit members, when they brilliantly now in that language design these things called features. So features It's something that we have now on the language, now natively, which is called promise. And the whole idea of this is that we need some sort of placeholder, some sort of tickets, right? That uh, allow us to eliminate time as a concerning factor wrapping around a value, and we need that natively. So promise now lands to the language, and they give us this ability to actually give us this value once that is complete, and now return is this trust issue generated by callbacks, as well as this inversion control, because now promise behind the scenes, you can think of this like a callback manager, or a promise, or an event listener, if you are now familiar with event listener programming. So you are now subscribing to that, and by the time that that value is there, all right, I want you to now run this set of instructions, run this callback. And the other is that when that is, when for some reason fail, I'm going to now I can now get the data out of that. What will happen here? So it also now help us to provide this data flow and flow control of our asynchronous operation, which is a great thing, and that's what we have, for example, other statements or another abstractions like all settle, array, all settles, dot any, and race, where each one of them help us to cover most common operations when we are now running multiple promises, right? A series of promises or a series of eventual values, right? And that's quite interesting. So we have promise.all settle, where promise.all is, hey, I'm going to fulfill if all promise are fulfilled, or reject if any is rejected. And they all settle and is say, hey, I'm going to give you all the promises settled, whether it's fulfilled and rejected. So you can now fine tune is what you want to do more about. This is perhaps more useful for doing some rollback operations, especially if you're gonna talk to databases as it is. So now that's great with promise. We also look at how can we make our own promise and write our promise to actually help us to coordinate this. That help us to don't think about time as a concerning factor, okay? And then now how promise actually comes from this functional programming language, for example, like monads. And what is a monad at the end of the day? Well, I can describe that in terms of the functionality, or at least one of the use case, which is, hey, this will allow us is to represent state change. So in any case, this has come from functional programming, all of its concepts, and this is another course that we're going to later on take notes out of this. And as we look now at other tools that are provided now in the language, for example, like generators, and what generators are, that is give us the ability to pause and resume a function execution. So functions by default have this nature of run to completion, where they say, hey, you know what, I'm going to evaluate all of these statements, and that doesn't mean that I won't evaluate a function call. So if I find a function call, I'm going to now add to the call stack and going to now evaluate that function, and I'm going to do that until there is no more functions, or when there is a stack overflow on the call stack. So this call stack has a fix or has a limited size that varies that. So this Stack Overflow can happen when you call a function with a stop condition, so infinite recursion or deep recursion, even with a base case, if the necessity is too deep, or what you're doing is extremely deep chains of normal function calls. And that's very, very interesting. If you actually now make functions call too much. For example, let me actually now make an example here. Alright, so for example here, so each browser now has its own limit here. So what I'm doing is just defining is now a function that call it itself. So it's adding all of these call stack, all of these functions to the call stack here, okay? And it tells you, say, hey, internal error, too much recursion, right? But again, this is now a way of how you can do this. If you call this 100 times, well, that will happen. You may wonder, what is the size of this call stack, right? And that's a valid question. Okay, and this is quite interesting. Okay, so they are implementation details. Um, So, but in any case, as you can see, I just want to bring that out, okay, with this call stack and recursion and how an Stack Overflow can happen. So, with these generators, again, this is a particular tool that is to describe behavior needed in the language, pretty much like promise, right? What promise describes is that, hey, we need the idea of some sort of placeholders to eliminate time as a concerning factor, wrapping around a value. Great. And the other here is generator, is that, hey, we need some behaviors to pause and resume the execution of a function, of a function. Or in other words, we need a way to describe and state machines. So generators is a syntactic form to do that. So these generators, which define you now with an asterisk and let you define all of these different statements until you yield something, okay? We give you now the ability to pause and resume, pause and resume, pause and resumes, and also act as a message passaging, right? So this is known as the function that this function allows us to describe is this kind of stuff. In this case is this behavior that we need to. We can use these iterators and callbacks to do that, but that requires a lot of works. And iterators is just a way to is typically a way to stepping through a data that we say, all right, in our case, these iterators is stepping through the flow control. And that's quite interesting because this is not only allow us to generate values, as the name suggests, which is a pattern from Python, and you can start to think about why actually this come here. And also is that help us now to land, or this tool land to the JavaScript as a way to now help us to deal with this particular problem that we have with promises, which is non-local, non-sequential reason about it. So with the generators, specifically the async and await, but with generators, now we can define as our flow control of our execution, okay? And we can now is, in the context of the generators, is anytime someone get into these flow control or these generators, evaluate that statement even in the middle of a statement, and then yield that and pass control as well as a value for that. Pass control to whoever now control the iterators. You have to be careful with the iterators because that can lead us to several undesired state in your application. But in any case, we also look at how can we, by just purely using generators and promises to native tools in our language, how can we now create is this sequential and local set of instructions for our asynchronous code. And that is fantastic. That is huge, my friend. That is huge completely. So on that topic, as we move on and describe is how can we use these generators and what it allows us to do, and when we ask now questions like how do we handle a series of events that we receive that from an event source, and we want to now apply some sort of transformations or some step to each individual steps, right? So for example, UI events or server events. So Promise can help us here. Unfortunately, Promise is not a good way, or it's not a good abstraction that help us here not to handle this series of events that happen over time. And if you look at how you can use perhaps the least context to do that, also how that actually doesn't help us here, and because is, well, we have now the responsibility tightly coupling the setup, which means that how we're gonna connect, or the source of that the event source, and when we want to consume that. So now enters here observables. And observable is this idea that, hey, we need a way to handle from an event source is individual unit of data, apply some series of steps, and then distribute that in our systems. So you can, so if we boil down this to, we say, hey, let's go to now is make this, how do you call it, observables, in a way that, let's gonna make this series of it. Let's gonna make this observable, at least in the language. Well, let's gonna look now at these observables for a more practical example, and that is, well, in the spreadsheets. And how do you have in a spreadsheet is values and calculated values, and how now when you modify the calculated values or the values that depends on that, you actually see that reflected on all the other cells. Again, I don't want to dive deep too much into this example, because what we really care in today's video is the RSGX, okay? This one. Because we don't have that natively supporting in the language, and if we boil down now observables to a more technical aspect, so we can be on the same page, we say an observable is, you can think of an observables as an adapter hooked to an event source that produces promise whenever an event comes through. And this is quite powerful. So anytime you want to, or anytime you, for example, which is something that we're going to do in our case with RxJS, is that anytime we now defines this sequence of data or this time series of data, we want get a promise out of that, so we can resolve that. So that's quite interesting, and because again, Observable is not natively supported right now in 2024 in the language, we look at RxGX, which is now a library made by some smartphones and Microsoft, and we got this stuff that help us to say, hey, you know what, let's go into is again, folks in Microsoft has this kind of problems, as I mentioned before, with the synchronicity, and they decide to come up with some sort of pattern in a library that is huge, but in our case we're gonna see how can we use these tools to help us solve most common problems. Now, RxGX was initially developed in Java, and they poured out to different languages like Python and C#. So RxGX, and here we're gonna look at how can we create observables, how to test those observables, and we're gonna look at manipulating data and time with observables, and eventually orchestrating multiple API requests. So with this observable, particularly looking at this library, that you can think of RxGS as a Lodash for events. So Lodash is this very convenient utility functions for allows to work with objects and arrays, and also with functional programming. So since a promise is an eventual value, an observable is a series of eventual values. An observable is an adapter hooked to an event source that produce promise whenever an event comes through. So we look at one of the basic stuff here with JavaScript developers, or at least with observables, and how we now, if we want to be hired. So we are employable because we can most of the time the API doesn't support all of this UI stuff. That's one of the main reasons why, as UI especially, we have jobs. Okay, so we in the middle create some sort of rubble gobble machines in order to get that UI in place. And I really love that particular analogy, man. It was interesting. So we went through a basic overview of observables, of and from. What is the subtle difference between them? So if you need to define some sort of promise or arrays or iterator objects, you use now from. If you want to define is now a strings of primitive string objects, boolean nulls, and also objects. Okay, use it use of when it is nothing like an observable, when it is nothing like an eventual series of events, or when it's not a series of eventual values, right? So even though in from you can use that with a, that's interesting. You can use it that with promises. So you can use it that with array and promise, an object with subscriber methods, aka similar API like a Svelte stores. Exactly. So for example, is you can now subscribe to this. So for example, from RxJS. Okay. Create an observable from an array like object, a promise, an iterable object, or an observable like object. So the question is that what is an observable like object? Let's get into this. Observables are a lazy push of multiple values. And they'll fill the missing spot in the following table. So you have single and multiple. So if you pull and push, okay, this is to pull data from that, or this is to push data from that. And the other is multiple. This is an iterator and an observable. So an observable, a representation of any set of values over any amount of time. And this is the most basic building block of RxJS. So as long as this is now an observable, which is subscribable, as long as it has now the subscribe methods here as they're described here. So froms are used for arrays, promise, and object with subscribe methods, right? Similar like the API Svelte store or Redux store, I'm assuming here. And when not to use from? Well, when you need just only to send is series of events or series of data, primitive like or single objects. And well, this is the way of how do we listen to this. This is the legacy one, value, errors, and third arguments, incomplete. And now we have this new way of listen to the or to subscribe. And there's some nuance here because yeah, there's some nuance here. Because let's get into now to actually is run that friend. Not at all. Basic observables here.
So I'm going to kind of take this spin real quick. So I have this very kind of simple example right here, where we have of and from. And one of the reasons we're taking a tour here is you're going to try this out yourself in a second in a slightly different file, but kind of walk you through what we're going to do here. One easy way to test observables is, So as we break into the exercise, right, this is a good opportunity for you.
Well, this is, let's go to now the code here, specifically here, in basic observables and how you can create your own observable here. So anytime you define the setup and the consumer here, this is a new instance of an observable is an observable is created, right? So this is our setup, and this is our new instance of our observables. Okay, good. So come with me, do that. There you got it. And as you can see, it is this one, right? So this is how we create all of this. And by the time that now we get all of this data, all right, this is now synchronous data, right? Similar for this. Should create an observable from its arguments. And there you go.
So the question is
exactly. This is off, and here we're gonna create now is an observable. This is observable $. This is just a convention from an array like or an iterator or an iterable object or a promise or an observable. 1, 2, 3, 1, 3, 4, right? And then we now subscribe that, which is create a new instance of this observable.
See what's running, and this one passes, right? And yeah, from is very similar in this case. Let's grab this code here.
Does the expect method execute before the observable resolves?
Yes.
Does the expect method return after the observable executed the code?
Yes. That is a great segue, right? So yeah, one thing. So the question is for asynchronous events, doesn't just get angry and ask for some kind of way to know that we're done.
Exactly. And again, all of these are. This is sequential. Or this is synchronous observables. Okay, this is synchronous observable, so you don't complain about that because well, in this case with from we say, hey, observable dot subscribe. So by the time you now create this new instance, okay, of this observable, I want you to now walk through each one of those data. In this case, we'll walk through this data. But what happened when the data is not there and we need to wait for that data to come? Stay with me. So you get value here, and then you say, hey, this is now result.push. And you're gonna push that value there, and by the time we run this code, all right, they're using is Jess for that, not Vite. That's interesting. In any case, npm run tests. I don't think it will work because exactly we need to install the dependency here. Okay. Say concurrently npm UI API and npm lessons. Okay, yeah, they're using it now concurrently. Somehow there is some sort of errors here. Anyway, okay, observable and all that kind of stuff.
Complete, right? And so what we could theoretically do here is we only care about the next value, which is put in that function, right? If we need to wait for the observable to be done to do something, then we can use complete, and that's when we would run our expectation. So in here we have an exercise with creating observables, and the reason why I love that question so much is kind of towards the bottom we have some situations where we're creating it from a promise. So ingest, if it is an asynchronous test, you can pass it a done as an argument in the it statement, and then you call it whenever you are in fact done. So as we break into the exercise, right, this is a good opportunity for you to answer this question for yourself. And we have a series of just kind of making observables from all sorts of different things. So you got to see me do it with the simple version. Now I give you the hard version, because that's fair. And kind of go through some of the basic versions and kind of, yeah, exactly, answer that question for yourself and find out exactly how exactly we would go about testing asynchronous value versus a synchronous value, so on and so forth. Cool. So if you...
This is quite old, by the way. Okay, that's one of the reasons why it crashed then. Because now they're using a particular version, nvn install. So now when you install this, it's supposed to run as expected. That's right. Full, of course, it is full of all of that. Very nice. If you run, it's a npm run test, and then you say, hey, just watch. It say it fails here. Because basic observables 1 2 3 wait, what?
So I do whatever you want.
It's a off. Basic observable off should create an observable from its arguments. From its arguments. Oh, that's right. I pass an additional value, and now everything worked as expected. But again, this is for synchronous operations, right? But what happens when we need to wait for that kind of data? Okay. We say sync observables. Right, and then you say, hey, git push origin. Well, git status say git push, git commit. Exactly. Synchronous observables. That's what it is. We are looking for synchronous observables.
We'll just grab this code from here.
Exactly.
Done as an argument in the it statement, and then you call it whenever. So as we break into the exercise, right, this is a good opportunity for you to answer this question for yourself. And we have a series of just kind of making observables from all sorts of different things. So you got to see me do it, the simple version. Now I give you the hard version because that's fair. And kind of go through some of the basic versions and kind of, yeah, exactly. You got to answer that question for yourself and find out exactly how exactly we would go about testing a synchronous value versus a synchronous value, so on and so forth.
Exactly. Because this is now how we're gonna do that. Create an observable exercise. Sync and a sync.
Cool. So if you, I'm going to give you a little bit of time to download, npm install, all that fun stuff. There are instructions on the side as well.
Is
If you just
skip
wanna run the
each
test
test
for
and
creating
basic observables.
which is where we're going to be doing this next exercise. You just run npm test creating and only run those tests. You do need to skip them, and then we will kind of go through them.
Basic
Exercise,
observables
you just run
test.
npm test creating and only run those tests. You do need to skip them, and then we will kind of go through them together. So the first one, again, these are just basically to get
Creating observable tests. Okay. Creating observable tests. There you go.
that are, it's one thing to look at a bunch of slides with observables on it. It's another thing to just kind of like play around with them a little bit. And so we're always going to kind of have a bias towards getting our hands dirty with some of the stuff and just playing around with it. This first one is not much different than we saw before. In fact, in this case, we went of and a single value, right? So we can unskip this one. And it's not too much different than what we saw previously, where we'll say,
Well, it's going to create an observable with just one single value.
one,
Exactly.
and then we'll subscribe to it.
So when you subscribe here is you are creating now a new instance of that observable, a new instance of this series of eventual values, or it's a series of eventual values.
I'm going to put that on my clipboard because I'm going to use it one or two more times as we go along. So just as we saw before, this isn't much different. Cool. So then we have this idea that we want to just have one of a bunch of objects, right? And this one is to kind of somewhat resemble a reducer in this case, where we might have a bunch of actions that flow through, right? We might want to then be able to turn that stream of actions that are happening through our UI, that are being dispatched, if you will, into an observable as well. And again, this one we're going to use of, but it is relatively the same basic idea, where we can pass in primitive values, we can pass in objects as long as we separate them out as arguments as well. So we're going to skip this one, and in this case, we will go ahead and say, and I'm going to just grab this, just those arguments as well. And we need to subscribe to it. If you don't subscribe to it, then the test will fail.
So what it's doing here, okay, you create these observables here with all of this data here, as again using off because you can use that off with objects. all of his
These
object
arguments
separate by a comma, like
as
that.
well.
Mm-hmm.
And
And then you need to subscribe to that.
to it, then the testing will fail because you will not actually put those values into the array. That's again
Because you are not creating because you are not creating this new instance that allow us to subscribe, or you can think of these observables as an adapter hooked onto an event source that produce promise or that generate promise whenever an event comes through. This is what subscribe is. You can think also as like a promise like, but for series of events.
Well, active creating an observable does not do anything. Observables only activate when you subscribe to them. Which, the kind of, there were some questions earlier about like frameworks. One of the really cool things about this is you can set up all your logic, and you can say, hey, when this component mounts, subscribe to this observable. When it unmounts, when subscribe to the observable. And now you don't necessarily have to like worry about any of these things. It's just kind of happening for you in this case.
Because all of this coordination is being taken care out of you. The coordinations of handling is this series of events and how you're going to subscribe to, or how you're going to now hook up to that event source and then disconnect that is being taken care from you.
Cool. So in this case, we just separated as different objects. Again, if you had an array and you wanted to use an array, what's the utility function that we use?
Wait, what?
In this case. Cool. So in this case, we just separated as different objects. Again, if you had an array and you wanted to use an array, what's the utility function that we use?
From.
From. Exactly. All right. Speaking of from, so here's basically the same idea, but in this case, we want to use it as an array. So here we'll say equals from, and now we're given an array instead of individual objects. For a lot of times, especially when you have things in an array, this is probably the one you're going to use just a little bit more. Go paste that in there as well, and then we'll grab these values. Right. So making some of these observables effectively pretty straightforward. Now, again, when you have all your values from the get-go, right, like you probably could have just used an array. This is really useful when we have things, when we're dealing with multiple observables, where we're getting different values out, and we want to turn it into a stream, and we'll see this when we start combining observables. Like, hey, I have this observable stream. Hey, I have this thing that's not an observable. I really need to make it an observable so I can combine those two streams together and do work with them. A lot of times you just need to convert your data into basically the same kind of format so you can use it throughout your application. Let's get this one as well. Validate that it works.
Basically, when you do the sampling, because this is sampling.
Check that.
Hey, this is a string of data, and this
so
is
here
string
we
of data,
have
this is string of data.
And I said before, like generators are kind of like observables, where they kind of, a generator will basically yield the first value, pause.
So, but with generators, it's a way to describe is state machines. So, the state machine that we want to describe here, right, is quite interesting. So we can now is anytime that we call this this value, we give us is now an iterator behind the scenes. We can now is subscribe. We can now is to call that using the new way of iterating through iterators, or this new syntax of iterating through iterators using the for of.
Yield the second value, pause. Yield the third value, pause. And eventually return the fourth value in this case. Now you look at the test, you'll notice something a little bit different here, which is we only expect with equal 1, 2, and 3. Does anyone know why?
Because that is our sequence.
Yeah, the return is basically a completion. Observables.
Exactly. So that is our sequence. So return is now end that.
Actually don't pass an argument to complete anyway. So the only things that are yielded from this one in this case are the 3 values. So we'll go ahead and skip this one. And we'll go ahead and we'll just make one from.
Oh, it's an iterator. So from allow you to create now iterators from that. Okay.
The other thing we have to do is a lot of times you
Of the
pass that in,
values,
create
but you need to create the generator because
itself, or else it do the thing. We'll say
observables.subscribe, because now the implementing is that interface,
awesome.
and then we're gonna get is
So maybe you wouldn't do this, but if
You should never expect to get that return value.
Where generators and observables become interesting together, we'll see this later, is if you have a generator that maybe is infinite, right? If you look at this one,
You're
this one's just
generating
1,
as a
2, 3 going.
sequence.
1, 2, 3 going for it, right? When we get to operators and we'll see making things into streams is great and wonderful. It is manipulating those streams and playing around with time that becomes a little bit more interesting. And that's where like we can have an infinite generator that say we only want values in a certain case up to a certain extent, skipping this many values. A lot of times your generator, if it was quote unquote infinite, needs some stopping mechanism, like your for loops, right? Otherwise you end up with an infinite loop. You try to iterate over it. Basically, an observable allows you to take out the difference between generating values. That can be the generator's job. Knowing when to start and stop, it becomes the observable's job, and we have a separation of concerns. And I will show you some code in a little bit that will basically, we'll see a generator that has a stopping condition. We'll see a generator that goes infinite. We'll then use observables to create the starting and stopping as well. Which means that you can then use the same generator multiple places throughout your application, and then let the observables, the different observables you're using in different places, be in charge of knowing exactly what to do with those values as they go through. All right, so now we have those asynchronous issues. Here we have one where we'll deal with a promise. So here we have just done function, which allows us to tell Jest when to actually check everything. So we can kind of go through here, and now we need to figure out not only when a value is emitted, that's important, but we've done that. We've done that like 3 times. We get it. But also knowing when it's completed, because it's when the test is completed that we need to actually check to see if the results will be right or what we think they are. So here's a promise. Results 1. We should see that result in an array. Let's go ahead and let's create the observable first.
So by the time you pass now these observables, which is hey off from exactly from the promises,
now
we need to subscribe that because it's going to create now this new instance of that.
And if I just give it an x value, this test will. Hey, let's make it fail. Let's do it. So if we do it the way that we've normally been doing it. Push value.
Because now it's gonna give us is
Run
now
it.
an observable.
Skip it if we'd like it to fail. But we'll run in this case, and it's going to fail because nothing got put into the array yet. Because basically we subscribed to the promise. The promise went on the event loop.
The promise went to the event loop, exactly. The promise went to the event loop, and the
right. Then the test went to see if there was anything in the array. There's nothing there yet.
There's nothing there yet.
The test failed, and then the thing got put in the array. Right. So in this case, what we want to do is we want to wait until the observable has been completed. So here we'll say next, we'll put the value in, and then when it completes, that's when we'll go through, inspect everything, and then tell Jess that we're all done. So run it again. Right, now it passes. Right, so there's nothing synchronous or asynchronous about observables, and we'll see a little bonus section at the very end, like how exactly this might work under the hood. But in the case of
exactly for synchronous operation, you can write it there. But for asynchronous operation, especially if you're gonna test your observable, it's like.
All right. So what happens when a promise rejects? So the nice part about from is that when you give it a promise, will kind of wire itself up to all of the kind of accoutrements of promises in this case. So what we can do is, what happens when a promise rejects? What do we use to find that error?
To catch.
Catch, right? And so basically, when it resolves, we get a next value. When it catches, it emits an error value, right? And then it completes. A observable made directly from a promise is very similar to a promise. It resolves, it rejects, and then it completes. Why is this useful? Because you can imagine a world where somewhere in observable, we might want to make an API request, right? And being able to then get that back into the stream is super helpful for us. So we'll go ahead and we will try this out. So here we have a promise that immediately rejects, and so what we'll do in this case is...
Well, create the observable from the promise, which is something that is accept.
And this promise.
Okay. And then we're going to subscribe to this promise to handle this now async operations. And they're going to pass now this object here.
And this one's never going to give us an X value. You could prepare for the happy path, but like this is a pretty straightforward promise. It's going to reject. That's all it knows how to do is reject.
So incomplete or on error.
Now, the thing about errors with observables is error is effectively a completion state as well, right? When an observable encounters an error, it's done. It unsubscribes, game over.
Okay, interesting. When a subscription or when a observable is find an error, is that?
Right. So we can actually put our done logic in this case in the error as well. So
Mhm.
this time, instead of getting nothing like complete, we'll at least get a copy of the error. And so here we
You say,
will
hey,
go ahead
expect
and
the error
grab our test logic.
to be something terrible happen because this is what we throw to the in a static way.
Awesome.
All right. Okay. So, so yeah. So that'll be all for this video.
One of the
Take
questions
care.
that we got earlier
Bye
were a
bye.
little bit more